Thank you for joining us for Gordon and Benson's presentation, Accelerating the Internet of Things in the U.S. The program will begin momentarily. Hello, and thank you for joining us for this virtual presentation. The program will be starting shortly. Just a reminder that your video and audio will remain off throughout the discussion. Please submit your questions at any time during the program by clicking on the Q&A icon at the bottom of your screen. I will be reviewing and compiling your questions and answering them at the end. In addition, we encourage you to use the chat feature to communicate with the panelists and other attendees. At this time, I would like to introduce Stephen Jensen of Davis and Keilthau to welcome the presenters.
Good afternoon, everyone. As a longtime business resource for the manufacturing industry, Davis and Keilthau welcomes the opportunity to support the 10th annual Manufacturing First Expo and Conference. At Davis and Keilthau, we recognize the huge disruption that many manufacturers have experienced, from supply chain shortages to hiring challenges to revenue loss. The need for flexibility is more vital than ever before. Our team of business, employment, and litigation attorneys is helping manufacturers address everything from implementing better governance plans to assessing their real estate and intellectual property assets to improving their supplier contracts. Together, we're working hard to help manufacturers grow and thrive. Davis and Keilthau is pleased to sponsor this 3 o'clock presentation where Gordon Feller and Benson Chan will report on a special research project on the Internet of Things.
Thanks very much, Stephen, for introducing us, and we appreciate Davis and Keilthau sponsoring this program, and we're excited to have everybody participating. We're coming into the home stretch on the day's program, so we're going to try to keep you engaged so your coffee and donut or whatever the healthier alternative is jazzes you up as much as we do. My job is to kick off the presentation with a little background and context. Benson and I are sitting here in Silicon Valley in Northern California on a not smoky day, so we feel lucky. And we're glad that we're able to share with you a little bit of insight that we've gained as a result of undertaking this project. The first slide that Benson's going to share with you, and he'll take over after I finish, helps to frame a little bit of who we are. That's not the first slide, that's the 5th slide. There we go. Next slide. So we're going to basically take you through a quick introduction that I'll provide you, and then a project overview will help you get a context for who we are in this particular effort that the federal government has asked us to undertake about Internet of Things and the gaps that need to be filled. We'll then transition to the third part of the presentation, a little overview about why Internet of Things is as important as it has become for manufacturers and for those that are working with manufacturers. We'll then have the fourth section, a little future view of where IoT is heading, and then we'll open for the discussion. And between number 4 and number 5, there'll be a polling question. And then we'll close up and wrap up with you on time. Next slide. So a little bit about strategy of things. I've teamed up with the group of Internet of Things specialists here in Silicon Valley, Benson being one of the co-founders of Strategy of Things. And the idea is to really hone in on the ability of connected objects, connected infrastructure, connected manufacturers to solve big problems that have really not been easy to address, not just efficiency problems, not just resiliency problems, but all sorts of interesting problems that are now being solved in new ways with advanced digital technologies that are helping in a positive way, we hope, to disrupt the industries like manufacturing that we're focused on in this study. Next slide. So a bit of background before you learn about the study. I'm based here in Silicon Valley since 1983. Worked at Cisco and IBM and Hewlett Packard and a whole host of other companies who've been exploring the future of digital innovation, particularly around what used to be called machine-to-machine communications, which, unbeknownst to almost all of us, is the largest proportion of the communications in the world. It's not between people or between people and things. It's actually between things and things. And that machine-to-machine communication is now becoming an asset and a reliable resource for manufacturers and for others, including in the services industry. And you'll find lots of my writing about this and my presentations about this if you Google my name. And we're afterwards going to share with you some of our contact info so you can be in touch with us if you have questions that don't get answered today. Benson has also been in Silicon Valley for decades, has worked with companies like Cisco, where I got to know him, but also Control4, which is an edge computing, edge awareness solution, Hughes Network Systems, NASA, PricewaterhouseCoopers. We are not joined today by our other two primary colleagues in this project, Renel Paramel, who's another co-founder of Strategy of Things, based here in Silicon Valley, and Christopher Rehberger, who's based in New York, where I got a chance to work with him at Cisco headquarters. Next slide. So let us tell you a little bit about what this Internet of Things research project from the federal government is all about. NIST is the National Institutes for Standards and Technology, and it's part of the Department of Commerce. Department of Commerce is a huge, sprawling organization that includes NOAA, the National Oceanographic and Atmospheric Administration, and lots of other parts of the federal government that you do or do not know, but NIST is probably the most important that you don't know about. It was established, I think, more than a century ago, and its purpose is to really help enable industry and government to measure and manage the things in the world, whether it's digital things, physical things, systems. And so the standards of measurement that we've become accustomed to, like bits and bytes, the ability to standardize important things like our USB connection into all sorts of digital devices, you can thank NIST for helping to lead the charge. So our project is called Economic Research and Analysis of the National Need for Technology Infrastructure to Support the Internet of Things. What that really is a research project that looks at the top gaps, the key gaps in the technology infrastructure. That's research, that's development, that's commercialization, that's connectivity, that the federal government should direct future investments toward. It was awarded to the Strategy of Things by a part of NIST called the Technology Partnerships Office in a competition with a lot of others. And it's a 2-year study that we began in October of last year, and it will conclude less than a year from now. So we're pretty much right in the middle of it, which is why we wanted to present to you today. And I will say, share your questions and comments in the chat during this. Jenny will have a chance to review that, as I will, while Benson is speaking in the next phase. And before we do that, I think we have Benson to kick us off for the second part of this presentation. So Benson, the floor is yours, and we're looking forward to the rest of this.
Okay, thank you, Gordon. I think before we get into start, Jenny, there's a poll for one question. If you could launch that. Let's see. There we go. Thank you.
Poll results will show as it's happening. There you go.
Okay, perfect. Let's just give it a few more minutes or just a minute. Okay. Okay, thank you. So I'm just looking at the results. So looks like a lot of you are still not sure. A third of you are using some IoT. And then there are some that are planning, maybe about 20% are planning, but haven't started yet. Okay, let me stop sharing this. Thank you very much. So you can see this. Right? So this is a pretty good broad overview. About half of you aren't sure about, say, about another half are planning to have started, and then about a small percentage are not planning to. Okay, thank you for that. Let me just go into the next. As Gordon mentioned, we're looking at this study. We're looking across 10 industries. These industries were selected because of their contribution to the national economy, the national GDP, but as well as what we thought IoT would have a positive impact on the industry in general, and also the industry's strategic and economic importance to the US. So there are a lot of other industries, but these are the ones that we felt were the top 10 that we wanted to look at that would be relevant. Okay. Oops. So okay, next slide. So before we go too far, I wanted to do a little bit of a level setting and explain what IoT is. So some of you may know, some of you may have talked to a lot of different vendors, you hear a lot of different things, right? So you talk to 10 different people and you maybe get 3 or 4 different definitions of IoT. And why is it important? It's important because we wanted to kind of narrow down, have a certain definition, because that's what NIST is looking for. And so, at a very simplistic level, right, that IoT is a device, right? So a device could be hardware, it has some software on it, has a radio for communications, it has a sensor that collects data, or it has an actuator to do something, right? So this device then connects out to the internet, and most likely you see it as something that you can access from your browser or from your mobile phone or even from a back office system. Right? But in general, that's a very high level, 100,000 foot view of what IoT is. And this next slide, I'm going to go a little lower. We'll talk about it from an architecture perspective. Right? So again, it's very simple. So you have these things or devices. These devices connect out into the internet or to the cloud, right? And that information is aggregated, stored, processed, and then it gets put back and integrated back into the manufacturing system or to a back office system, ERP, or some kind of operational system, right? And where it's used by the users to do something with. Right? So that's a very architectural perspective of that. Now, you've heard the term edge, and you heard the term cloud, and you heard the term on-prem. So the edge is nothing more than the point of use, right? It's where the device or the sensor is being used. The cloud is this place, there's a consolidated data center somewhere, whether it's an Amazon data center or a Microsoft data center that's out there that collects all this data from the different sensors. It does something with it, right? and then your on-prem systems, your on-premise, on-site systems integrate into that to pull the data down where you use it to do your analysis or to make some decisions. When people think about IT, right? When they talk about IT, they're really talking about the right-hand side, right? So this is the domain of IT. When we talk about IoT, we're talking about this part of it, right? To the left of this. Both IT and IoT interact with the cloud for their own purposes, but that's where the point of intersection is. So things could be sensors and actuators, it could be meters, it could be devices, it could be on machinery, it could be a drone. Right? Now they communicate with and they get into the cloud through a lot of different ways. So there are different wireless connectivity technologies. You've got short range, right? It could be Bluetooth, it could be near field communications, it could be Wi-Fi. So those are very common methods. When you want to communicate something that's a little further out, you have a device that's sitting on your customer site, maybe 20 miles away. So sometimes you're able to connect through Wi-Fi, but if it was out in the field, you can communicate through cellular, which is very common, or through these newer types of long range, low power wide area networks like LoRa. Right? So that's or Sigfox or NB-IoT, right, through the carrier. So those are different types of technologies. So those are somewhat new. Sometimes that processing, that the data is collected, sometimes that's done at the gateway, or sometimes it's done on a device that's on a particular machine. So not everything has to go to the cloud, but some data does go to the cloud. The data that goes to the cloud is then aggregated, stored, normalized, acted on, organized, archived, and then it's made available by the different systems to use, right? Whether it's your SAP or some ERP systems. Right? So at a very high level, this is IoT, and this is how it's integrated and connected with the back office systems. Now, I think we've all heard the term or the phrase, "data is the new oil." Well, in many ways, right, this is very true. With IoT systems, the sensors, they collect data. That data is then routed throughout into the cloud or through the edge systems, and is acted on, where then it's made available to the users, who then use it to make decisions or to act on, or to analyze, or do something with. So it's very simple. The sensors collect the data, the cloud and the other systems act on the data to organize, store it, process it, and the users use that data to create some specific tactical actions to do. So why is the government interested in IoT? Part of it is that it creates a whole new set of efficiencies, but at the same time it creates new value, right? And those new value leads to new jobs, new value in the economy, new things that the economy can produce. Right? So there's a lot of value to that, but at a very simplistic level, let's look at it, right? So traditionally we sold or we bought products, right? It could be hardware, it's equipment, and you would buy a service or maintenance contract to go with that. Now, with IoT, what it does is now you've added a layer of intelligence and software capabilities to your traditional, equipment. Right? And so what that means is it has a lot more capabilities, but at the same time, you're not just selling maintenance, now you're selling new flavors of that. So for example, by having sensors on equipment, you can now identify when something's going to need maintenance, right? So it's just by the vibrations, for example, or they're seeing the temperature ramp up a little bit, they're able to detect those patterns and say, this thing may need service pretty soon. And so we could go schedule out a visit, and this way you maximize machine uptime. Okay? At the same time, with sensors, with connectivity, you can monitor the machine remotely. You could diagnose it remotely. You could troubleshoot it. In some cases, you can repair it remotely. But at the same time, you can see how it's being used. So you can monitor it. So that's another layer of service that you can add, especially if you have hundreds or thousands of these machines scattered throughout. This is a very convenient way to add a new layer of service. Now, what else can you do? Well, so with all the data that you collect, well, there's another layer of value, right? So now you can create some consulting services, right? You can analyze the data. You can then use that to provide some optimization consulting for the clients, right? And in this case, it creates a lot of additional value that wasn't there before, because now you're seeing data, you're seeing numbers, and you can optimize. You can look across the ecosystem, all the customer base, and now you could do other things. where that information then creates a whole new layer of services. So that's something that existed, well, that didn't exist before, that you can do now. At the same time, the data that's collected could be valuable to someone else. It could be another manufacturer, some complementary equipment. They could use this data to improve or enhance their product sets. And so that's something that's worth something to somebody, and they could then do something with that. So that's another monetization that didn't exist before. So you're creating a new market. At the same time, you could take that knowledge that from the optimization consulting or some of the new skill sets or even the data from other manufacturers, and you could create planning services. Right? And you could offer it back to the customer. You could offer integration services. Because some of this stuff there's a lot of new capabilities that they may not necessarily know how to do, or they might need to integrate into their back office system. So there's a new layer of value that's being created and new layers of opportunity. And finally, you can then create new digital products, right? Depending on what the planning and what the integration and what the data tells you. There are new services that can be created that's separate from the original hardware equipment. So from this, what you're seeing is that just by adding sensors and connectivity, there's a whole new layer of services and information services that can be created from your existing product line. But you can also extend that into new product sets, new service sets to create new value. Right? So this is why, in a lot of ways, the government's interested, because there's a lot of new value that's generated that some are existing, allows you to do it better, but some are just net new that wasn't there before that you can create. When you've heard the term Industry 4.0 or industrial IoT, and there's a lot of excitement, a lot of buzz, a lot of value around that, right? And it gets pretty exciting. Now, at the same time, you'll hear a lot of the analysts, and they'll tell you this great vision, and that great vision is very exciting. But if you look at where these use areas are today, it's really around 3 areas. And why is that? It's because you're solving today's problems today. Right? So it's not a surprise that when people are looking to add IoT or using IoT or selling IoT in manufacturing, these are the top areas. It's about improving your manufacturing operations, right? Maximizing machine uptime, making sure all your machines are being used, right? Doing better planning. It's about tracking where your assets are within the factory. And it's about making sure that they're not breaking down, right? So you always have visibility into where they are in terms of their maintenance cycle, and you can prepare, you can get those repaired or maintained before it actually breaks down. At the same time, you could take some of these exact same things and for the machinery that you sell, and you could apply for field service, right? So you can monitor and maintain a customer's piece of equipment remotely. You could look at doing the asset or predictive maintenance on that. Right? So those are areas of new value that can be created onto an existing service. So those are kind of the top areas today. Now, where is IoT headed? So this is where it gets a little bit interesting. Right? So today we're focused on stages 1 and 2, right? And those are some of the things we're talking about. These are things that you're doing today that we could do it better. Right? Then there are new things that from an existing product sets that maybe we're not doing, right? But it's within the realm of what we have today. So for example, you can create new software services or data services or consulting services, right? So those are extensions of your existing product line. Now, when we get into the longer term, and the longer term is where the government's starting to look at, right? Because in stages 1 and 2, a lot of companies are doing these things today. Now, they may have their own way of doing it, but they're doing it. In stages 3 and 4, these are about 5-10 years off. And this is where the government wants to get involved, because companies aren't doing those today, or they don't have the resources to, or really there needs to be some fundamental research that needs to be put in place in order to get there. So what is that? So for example, we've got the outcome economy. So instead of buying machines, you're buying machine uptime as an example, right? So all of a sudden it's very different. You look at the aviation industry, General Electric, they sell jet engines, but they don't necessarily sell jet engines. They sell thrust, and they sell engine uptime. Right? So all of a sudden, they're not necessarily just selling you an engine, but they're selling you the performance. Well, that's a very different model than what we have, and they're able to do that because the engines are heavily censored. Right? There are sensors everywhere, so you know exactly uh, where the engine is and what it's capable of and what its performance levels are, and they would then go out and service it before it drops in performance. In the last stage, we've got what I call the pull economy, and this is the end-to-end automation, that the fully automated factory, the so-called smart factory that's lights out, right? So for us to get there, there's a lot of technology that's involved. IoT is just one part of it, and we'll share what some of those are in the subsequent slides. But that's where IoT is headed, right? From where we are today to where we're going. It's a big jump. I think from 1 to 2 is a little bit of a jump. 2 to 3 is a huge jump, and 3 to 4 is an even larger jump. So we talked a little bit about the first two, right? Some of the use cases, things that we are doing today, we could do a little bit better. We could add in some new capabilities for some existing services that we didn't have today. So we talked a little bit about the outcome economy, right? So this is instead of buying a machine, you're buying machine or equipment uptime or lifetime or performance levels. It has to perform a certain level. The other thing that you're capable of doing is what we call think about it as Uber for manufacturing, right? By putting sensors, by putting connectivity, you're able to, and putting this capability out, allow there to be discovered. Now you're able to, for example, tap into, as you're manufacturing, you can tap into excess capacity or capability that you didn't know existed. Right? And you can monitor and see how that's going remotely. So this is just one jump, but with sensors and connectivity, you're able to do that more efficiently than you were able to do before, right? Because otherwise you would do it a very different way manually today and not necessarily at scale. Now, when we get to the last stage, right, this is the lights out automated factory. But at the same time, we could go well beyond that, right? So you get the end-to-end manufacturing and supply chain. So all the way from raw materials to shipping it into the stores, right? That part could be fully automated, full visibility. So that's, those are the four say, areas of use cases, 4 areas of focus. But to get there, it's pretty difficult. So what's it take to get there? And this is just based on some of the research that we're doing. So we know what we're doing today. We're putting sensors on machinery. We're putting it into the manufacturing process, so it allows us to get full visibility. Now, there's, we may think, oh, there's a lot of sensors, but in tomorrow's world, everything is censored, right? So instead of the factory having 100 sensors, think of the factory as having 20, 30,000 sensors on everything. We connect devices today. Tomorrow, we'll be connecting everything, right? So it's every device is connected. Every device is talking to each other, right? So we have the system of systems, right? So, but it's not necessarily that we're connecting devices, but it's how many devices we're connecting. It's connecting at scale. We talk about vendor ecosystems. So you may have an ecosystem of partners that you work with, that you co-produce products with, and you integrate that into your solutions offering. Tomorrow, we're looking at talking across industry and industry ecosystems, right? So it's not just your ecosystem, but your competitors' ecosystems, or maybe there's an adjacent market where they have an ecosystem. So you're talking across these ecosystems across the industry. So the amount of collaboration is much broader, much deeper. We analyze the data today. We use statistical analysis. We use machine learning. You're starting to hear a lot more about artificial intelligence, right? So artificial intelligence has really taken a big leap over the last 5, 6, 7 years, right? And it's doing a lot of things. But imagine what would happen if every device which is connected also has the capability to process intelligence, right? To do AI on their own, but now they're context aware. They know exactly what information from the devices that's nearby that they should act on. Right? So all of a sudden it takes artificial intelligence to another level, but at scale across thousands, tens of thousands of devices. one of the things that we talked about, especially with this pandemic, was called out is that we knew about the digital divide. And sometimes even when you drive, that you hit a dead zone on your cell phone. So we don't have true ubiquitous connectivity yet. But imagine if you had connectivity everywhere. And imagine you have not only connectivity everywhere, but you have broadband connectivity. What can you do with that? That's a foundational capability. At the same time, computing is getting faster and faster. Imagine if you could have an Amazon data center, the power of an Amazon data center, which is, I think someone mentioned a number to me. It was a $7 billion investment to open up an AWS data center. Imagine you had that kind of power in the form factor of a mobile phone sitting on your device. Right? What can you do with that? So that's coming. Right? Those are some of the things, but enable some of these things that's happening. Now, in order to pull all this together and make all this work, right, we're talking about operating and working in different ways. Right? So you're looking at new business models, new operating models. The government needs to kind of step up and start looking at new policies and new regulations. So one of the things that's happening now is that the technology is outpacing the policies that are out there. Right? So I met some guy not too long ago, and he does consulting. He's a lawyer, does consulting for the automotive industry. And one of the things that they're definitely afraid of is this liability of a self-driving car. Right? So in some ways, like, there's no policies. Can the cars do what they're doing? Some of the time they can, they're safe to operate in the street, but they're afraid to really just take off the safeguards and go for it because they're afraid of the uncapped liability. Right? So some policies need to be adjusted, regulations need to be put in place in order to enable some of this to happen. We talk about security and privacy now, but as you work across industries, work across ecosystems, you're working with a lot of data. You're really talking about trust at this point. Right? So security and privacy is assumed to be there, but trust is really the big issue that needs to be addressed. Right? To trust in the data, trust in the people who created the data, trust that the data will be used correctly. And finally, we get into the thing that people haven't talked too much about. As machines get smarter and smarter, really there's the whole issue of ethics. Right? As you program these, as you train these algorithms, what are you training it with? Right? And so there's a whole level of research that needs to go into exploring what that looks like. In order to enable these accelerators, there's a lot of technology areas of research and the technology that needs to be put in place. So, as an example, the edge infrastructure. Right? So imagine having the power of the AWS data center the size of a mobile phone sitting on your device. Well, in AWS, that kind of compute power is draws a lot of power. So now you have to worry about power efficiency and power management. So you got to get the power levels down so that you could have these devices sitting on your machines while consuming all that power. So a lot of research needs to go to that. As we go to a whole bunch of different devices, whether they're on the edge, whether they're on a mobile device, or whether they're on a car driving around, you've got a very different set of infrastructure elements that's all spread out. It's no longer just in your factory. It's outside your factory on your customer site. It's in the car that's moving around. So there's need to be new technology architectures to support that. We talked about some of these. I won't go through all of these, but the big thing here, really, I want to drive home is that as we move towards stages 3 and 4, what needs to be put in place are new architectures, new technologies, but also the scale at which we put them in place. Right? So in order to support that, it takes a combination of some of those accelerators that we talked about. So from our research, and we've talked to people across multiple industries so far, what have we heard? From a technology side, I think we keep hearing connectivity, we keep hearing about standards and interoperability. Right? Security is just it's always going to come up, but these are some of the bigger ones that we've heard. So connectivity, well, we don't have connectivity everywhere. So it's hard to do some of these things. So we don't have good quality connectivity. Sometimes that can be solved through technology. Sometimes it can be solved through policy, through investments. But you know, that's a gap. Another area of gap is interoperability and standards. So from a vendor perspective, they love for you to upgrade to the latest and the greatest every time. But there's a lot of equipment that's sitting around that's perfectly useful. It's just older, right? It might not be connected, it might not be smart, but it's still very functional, right? But it's not economical for many companies to go and upgrade that every year, right? So, you know, they could have hundreds of machines in a factory, of thousands, and you know, they can never upgrade everything. So they've got to use what they have, maybe upgrade to some new ones here and there, but all these got to work together, right? So interoperability is an area that we keep hearing coming up. And the people side, the skill sets. You know, in order to take advantage of this, there's new skills that's required, whether it's in data science or within technology. And the regulatory side, you know, there's a whole slew of things. I think data comes up a lot, privacy comes up a lot, incentives come up a lot, and liabilities comes up a lot. And then finally, there's the economics, the cost of some of these things. Some of these sensors, for example, can be very expensive, but you know, if it's one, two, it's not too bad. But when we're talking about thousands of thousands, then it gets very expensive to incorporate some of these into your machines or into your process, into your product lines. So what can research do? Can we create sensors? Can we create equipment that's lower in cost but at the same or higher operating levels, or performance levels? So those are the things that we've heard so far. Some of the gaps. I think so. Gordon, I'm going to turn this over to you.
All right. Thanks for taking us to this point. We thought that we should prompt you with these discussion topics. What role does IoT play in your industry in the medium term and the longer term? What are the IoT related technology barriers or gaps that you think we need to address and that all of us collectively need to overcome? And ultimately the federal government should be responding to. And then can we think long-term, like the 10-year timeframe, about the things that the federal government should do that industry is not now or not in the future going to do? In other words, filling those gaps that maybe are not going to be addressed by the private companies who care about this. So maybe we'll turn it over to Jenny at this point. One more slide here. Let's go to the next slide. Okay, let's leave that up for the moment. So Jenny, we have the option of Scott's question or perhaps the next pop-up survey question, polling question.
Yeah, we can start with Scott's question. So Scott is asking, what are the key tipping points to move toward outcome or pull economy?
Great question. Thanks for that, Scott. I'll start and then hand it over to Benson. So we think that maybe there are a few tipping points, depending, of course, on where you sit, right? If you're a manufacturer like GE and you're accustomed to selling stuff like a jet engine and you want to begin essentially transitioning to and getting your customers ready to transition to buying uptime and buying thrust and not buying the object, that very expensive and very powerful jet engine. And if you, GE, or another manufacturer want your customers to be in the frame of mind where they're ready, willing, and able to sign a contract that's very different than what they've been accustomed to signing, in that particular case, there's as much psychology in the tipping point as there is practical logistics or technology systems. Even when the systems work really well and all the sensors perform their task and all of the jet engine asset capabilities are performing optimally, the reality is many customers resist the idea of moving to what essentially is a subscription model. And we've seen in many industries this subscription model has worked pretty well. I mean, music, for instance, to take something very mundane, used to be all about buying the LP or the CD or the DVD, and then eventually the transition was made to buying the song, and now it's buying a subscription to a monthly package, in many cases nearly unlimited menu of choices. So that's a transition that happened in music, and it's happening in other industries. And you could say that once the technology is in place, the biggest barrier could be psychological. It also could be practical economics. Are the customers set up to transition from buying as a capital expense that technology, like the GE engine, to now essentially buying a monthly subscription, which is it's OpEx as opposed to CapEx. Benson, over to you for any other insights about the tipping points that will move us toward an outcome or a pull economy.
Yeah, and I would say, just keep asking. I would say part of it is like Gordon says, a little bit of the psychology. Another part really is your ability to be able to execute this. So if you were to go into a poor economy and you, instead of selling a machine, you're selling uptime. So you're taking on a lot of risk, and in order for you to offload that risk, you need to know exactly what's going on with the machines at every time, right? So you're able to maintain that service level agreement that you're able to say, yeah, you know, when this thing goes about to need repair, I know when exactly it is. I know I can see the monitoring of the performance, and I can see it drop off, and I should act on it before it does. Right? So that's one. You got to have full visibility into that. The second part, I think a lot of people don't realize is they're not able to respond in order to it. So you could set up sensors and everything, and now you have to be able to respond in near real time if something happens, as opposed to, oh, I see it happening. Okay, let me just kick it through my standard traditional processes. You know, it doesn't work that way. Right? When you're selling a service like this, you have to reorganize your company processes and policies to meet this new type of delivery, right? Which is a very different vehicle. But the third, I think, is really going to be trust in the customer to believe that you can execute this, right? Because that's the harder part. If you're airline and you're selling engines by the hour, well, you know, you've got to rely on your mechanics or the other guy's mechanics. And if you believe that the guy can go and deliver on it every time, then you're okay. But if you don't believe in it, then you're better off not going down that path. So there's going to be that trust that's built up. You know, these models exist today at small scale, but to do it at a larger scale, that's a little harder. So from the ability to have the infrastructure to support that, the ability to have visibility, I think those are some of the tipping points to that. And a lot of it's psychology as well.
And one other that is very practical that I would say people maybe ignore until tax day is the way the tax law is written. So you don't have a depreciation schedule for services contract, but you do for an equipment purchase. Mm-hmm. And so this is a disincentive for some of those who are buying big ticket items and have built their tax structure and their asset portfolio around a certain way that the tax code is written. And you know, this is part of what the federal government can help to lead, is encouraging a shift in the way that the pull economy or the outcome economy would have us, you know, oriented. We're going to address a lot of kinds of what would I say, gaps. So some of the gaps are in training. How can we train the next generation of engineers, technologists, business managers, accountants to think about the Internet of Things impact in the business that they're about to enter, or the government that they're about to enter as an employee? Can we train them in college and university, undergrad and grad school, in ways that help them understand not just the unique technologies that drive IoT, but the impacts in the economy, like we're now discussing? That'll be one of the areas that we may wind up addressing, and with your inputs, we'll hopefully identify more of them. So we have a couple of asks that you can see here on the slide in front of you. We have a survey that we've created to just pick your brain a little bit, and we'll keep you confidential, so your comments will be known only to us. If you are interested in being interviewed by us and our team and would have availability in the coming weeks and months, we're going to be doing some interviews with people like you who are on the front lines of business and who are looking at technology integration, particularly in this case, Internet of Things. We will be following up with a set of these slides that you see today, so you can share it with others. And we'll probably include some of the polling results. And then we hope you'll stay engaged and want to know more. So on the Strategy of Things website, you'll see you can indicate, with your email. And there we have the link to the website for our project, and we have the survey link, and then the contact info for us at these email addresses. I think we have one more poll before we wrap up in a minute. So Jenny, you want to pop that poll up and we'll ask people the final question? Here we go. What are the top challenges and barriers that you see in making progress around Internet of Things and incorporating Internet of Things? And it's multiple choice, so you don't only have to pick one. And here we go, off to the races. Very interesting. Looks like skills is in the lead so far with financial / return on investment, a close second. I mean, an almost close second, and then technology very, very close behind. Training and skills seems to be high. So there you have it, poll results. We also have Steve who shared his view. I think that's our Steve, moderator Steve, host Steve, sponsor Steve, saying that he hired college students who are going to school to be electrical engineers or electrical engineering technicians. This training gap is something that we're going to come back to. Closing comments to you, Benson, and then we'll hand it back to Jenny.
Okay, well, thank you everyone for your time and attention today. We know we're at the very end of the long 3-day session. Hope you found it productive. Please reach out if any questions or you were to get involved in this study. We'd love to hear from you.
Yes, and Jenny, thanks to you and your team for convening this. You did a great job.
Thank you, Gordon and Benson, for your time today. And thank you to everyone who was able to attend, and have a great rest of your afternoon.
Okay, thank you.